Hello, welcome back to our channel. My name is Jovanny Rodriguez from Wick Editor forums, and today we are programming this offline Google Dinosaur game in Wick Editor, but with a graphic refresher like this one. If you like this kind of tutorials, please help me to do more by subscribing to this channel. Also, the sprites that we are using are from PCUH user in itch.io. Please check out his material, it's really good, and at least for the sprites that we are using today in this video, they are totally free. Okay, now under the description I have put the Dino tutorial template. Go ahead and download it, and then just click open and upload it into the editor. So let's press here and change the name from Dino tutorial to Dino game. Let's leave 60 frames per second and the width and height in 600 by 500 pixels. Let's hit apply. Now let's go to the layer and rename that layer to be the code layer. And let's add a second layer and let's rename it objects. Now let's go to the asset library and see what we have. We have a default font. We will be using Lemon for this game. Also we have Cactus 1 and Cactus 2, the Dinosaur, the ground, and the mountains. Now let's open the outliner. So let's start with the mountains. Click on mountains and then add to canvas. Then let's try to put these mountains aligned to the border here. We can see the values. Put 0 in here, 0, and then 0 in Y. And that will be it. Let's go to the ground. Let's do the same thing. And just put 0 in X, and then in Y just put it somewhere here. Let's put 0. Now let's put the first cactus. We will be spawning this cactus on runtime, cloning them, so at the very beginning they will not be seen by the user, so this dark area here will not be visible by the user, but by now we haven't covered it yet. But, let's apply a filter here, dot wick, so we can only focus on the wick objects. Second cactus. Now let's put Dino into the stage, right there, do the same thing. Now let's do the score. Let's press text here. Score. Let's choose Lemon right here, the first one. And let's put it somewhere here. Let's decrease its size a little bit. Let's do a duplicate. Let's put it about there. Let's change it to 0, so that would be our score. And let's change its color to be dark blue. Now let's do a text background. And put it below the text. Change the opacity to be like 0.2 or so. Change the color to be white. Now copy the score label and duplicate it. And let's use this for the game over text. Now increase its size. Now let's name this text to be JO for game over text. Then the score label to be score label, and the score text to be score text. Now let's see what we have inside the dinosaur and also inside the cactus. Let's start with the dinosaur. Press here under Dino, edit timeline, and then you can see that we have 2 frames. The first one has the collision, which is invisible right now, but it's this blue square here. If I increase the opacity, you will see the collision box. This is to program whenever we hit a cactus, but it should be invisible for the users. And then we have this frame here for when the dinosaur is running. Let's hit play. And this one whether the dinosaur is jumping. So if you want to go inside the dinosaur to see the frames, you can see the dinosaur running frames, and you can see the same thing with the jumping ones. So let's go now with cactus one. As you can see, we don't have 2 layers, but we have a collider object. Same thing, it's transparent for the user, but it will help us to program a collision system better. Same thing with the second cactus. An invisible collider, named collider. Now let's go to coding. For this example, this tutorial, I'll be trying to put all the code inside the main frame here under the code layer, first frame, at the default script. Also, I'll be using object-oriented programming for this game, so you can taste a little bit what's going on with that programming method. Let's start with defining some constant that we will be using for our application. I have created these 9 constants. These first 3 are for the player to control the dinosaur. For the left, it will use the left key. For the right key. And for jumping, it would be the Z key. Then we have a constant for the left corner of the stage, which is this part here. Another constant for the right corner, which is the other corner of the stage. Also, we will have the ground underbar Y, which tells the dinosaur where the ground is. Also, gravity for the dinosaur when it's jumping. Jump force for the dinosaur to jump. And also ground speed. Now let's define the classes that we will be using for our game. The first one is the scroller. Equal to class. Constructor. And also update. All our classes will have at least these 2 methods. So I will go ahead and copy these several times and then rename them. So another one for our cactuses. Cactus. Then another one for our dinosaur. Let's put maybe Dino player. We need a level system, so let's also use one level system. Another one for our main game manager. and then we will need to instantiate that game manager. Also, the game manager will be in charge to instantiate the other classes, but also to update them. So in this way, we will only put game manager.update into our update tab. Let's include the update tab. Timeline update. Then game manager.update. Let's start with the scroller class. This class will be in charge to moving the ground and also the mountains. And first we want to accept that clip, the clip that we want to move. Then where the patterns repeat in X coordinate, repeat X. And the speed. This dot clip equals to clip. Then init coordinate equals to this dot clip dot x. Then this dot repeat x equals to this dot init x minus repeat x. And then this dot speed equal to speed. Then at the update script, we want to move the clip at the speed that the user enters here. So this dot clip dot x minus equals this dot speed. Then if the clip reach the repeat pattern, then we want to reset the x coordinate of the clip to the init x. Now we have to instantiate the scroller class for the ground and the mountains, and then update, put this update script into our game manager. So let's go to the game manager. Here. Let's start with the game over flag. This dot game over equals to false because we just started to play. Then this dot player. Now we will be instantiating the Dino player. So we do new Dino player. Now we want to instantiate the scroller for the ground and for the mountains. So we need one for the ground. So this dot ground equals to new scroller, but the scroller accepts 3 parameters. So let's put it without parameters first. Mounts, and then we will be looking for these 3 parameters. Let's go to the scroller. And the first parameter is the clip that we will be moving. So at the scroller for the ground, the clip will be ground. And for the mounts, it will be mounts. Then for the repeat pattern, repeat X, ground, if you click here, you will see that the pattern is repeated every single 64 or so pixels. So you will see a small curve and then a large one and then a smaller one. And it will repeat over and over every 64 pixels. So the repeat for the ground will be 64. And then the ground speed, which is the third parameter here, we have a constant already for that, which is ground speed. Let's put it into the third parameter. And for mountains, the repeat pattern will be 600. As you can see, you have the same picture repeat itself every 600 pixels. So that's the number for the mounts. Let's go there and put 600 here as the second argument. And then for the ground speed, we want the mountains to be moving slower than the ground, maybe 10 times. So let's do that. We can divide ground speed by 10, and that will do the trick. Then we need to instantiate the level system, which is from this class. At the beginning, we want this game over to disappear, so we can set this game over text to empty. So let's do that. So it will be at the game manager constructor, which is the you can see the constructor as initialization code. It will only run once. Okay, so let's do that. It will be game over text dot set text to empty, and then in the update script we want, if we are not in game over, which is this dot game over, then we want the ground to be moving. Update. So this ground.update function is in fact the scroller update. If we go there, you will see that the scroller has an update function that it will be moving the clip that we want, in this case the ground, at this speed. Then we will do the same thing for the mountains. And even though the other updates are empty for now, we will be adding them, so we don't forget about it. So this player update, and then this level system update, and then we can test this out. Let's press play. As you can see, we have our dinosaur running. We see the scroller function working fine, which is mimicking an infinite floor or ground. And also the same thing will repeat in the background, as you saw. It's repeating the background over and over. And there is a good parallax effects going on, which is nice. The game over text disappeared as we expected. Now let's program the dinosaur. Let's go to the code and let me just close these classes and let's go to the Dino player. So for the Dino player, we don't need any parameters or arguments entering to this class, because we know on ahead that the only clip that we will be using for this is the Dino clip. So for that, let's start with the clip. This dot clip equals Dino. Then we need to define whether the player is jumping or not. So we will be using this dot onGround equals to true. So we start on ground. Then for the y coordinate, we want to use our constant, which is ground y. For the jump velocity, since we are on the floor initially, we will be setting the jump velocity to 0. Then for the moving speed of the dinosaur when it is running, we have a variable called speed, and that will be the same as ground speed plus 1, because we want to move faster than the ground. Then we also be keeping within this class the score, the user score, which starts in 0. Then we can initialize the score text to be in 0. So let's do that. Score text dot set text So for the Dinosaur class, I will defining 2 extra methods, one for moving and the other for jumping. So the update will be calling those two. So let's do that. This, the moving, and this, the jumping. And also we will be updating our score every single frame. So let's copy and paste this, and let's increase the score by 1 every single time. We could test this out. Let's see. As you can see, we have the score moving every single frame, and we can stop and then play, and it's supposed to restart at 0. Yep, that's working fine. Let's go back to the code. Let's go again for the Dino player class. Close the others. Okay. So let's program the moving method or function. So we can say if we are pressing the left key, we are doing something, and if not, and if we are pressing the right key, we are doing other stuff, right? And then we can put our cursor inside the if statement, go to input, and look for the one that says is key down, and then instead of be the A key, we can go to our constant and say left control, copy, and replace that to be left control. Let's do the same thing with the right. Let's put the mouse into the inside the if, press the is key down, and replace the A by right control. Okay, now when we press left key, we want our dinosaur to be moving left. This dot clip dot x minus equal this dot speed. But we also want to limit the player to be inside the screen. So if this dot clip dot x is less than the left corner, we have that variable already defined, which is left corner. Then we set up our dot clip dot x to be left corner, and then we can copy and paste this and put it into the right when the user press right key, and the direction will be the other way, will be plus equal to this speed. And then in here we will be putting if the x coordinate of the dinosaur is greater than the right corner, which is this one, copy, paste. We set up the x coordinate to the right corner. I think we can test this out. Let's go play, and we cannot be less than the left corner or neither outside of the right corner. This is good. Now we want to program the jumping. This is a little bit more complex, but it's not a big deal anyway. So we will have 2 states, one whenever we are on ground and the other when we are not on ground. So let's program those. If this on ground if this ground where we are not on ground means that we are jumping. So the first thing that we want to monitor is whenever the user clicks the jump button. Let's do that. If we are on ground, we want to see if the user pressed the ground button. Input if is key down, and then let's go to the constants, jump control, let's copy, and then replace that A, jump control, and then if the user pressed the jump button and we are on ground, then we want to be not on ground. So let's change that variable on ground to be false, because now we are supposed to be jumping. So we have J velocity, which is jump velocity. So we will be putting that to be not 0, velocity. But we have a constant for that velocity already. So let's look for it, which is jump force. We will be applying some value into the velocity, and then we can say this dot clip dot go to and stop jump. So that part is saying to the dinosaur to go to this jump frame. If you notice, the frames has names. This is wrong, and the second one is jump. So that's for the animation to happen. Okay. Then let's go back to the Dino player, to the jumping. I think that this will be sufficient for our dinosaur to start jumping. Now, when we are jumping, we need some gravity system so the dinosaur can return back to the ground. So the first thing that we will be doing is reducing that jumping velocity based on gravity. So let's do that. This dot J velocity, let me copy and paste this, it's easier, plus equals gravity, and we have a constant for gravity as well. Copy, paste, and then we want the clip to be following the jumping velocity. So clip dot y, because it's in the y coordinate, plus equals J velocity. So that we need to verify whether the dinosaur touched the is on the ground again, so we can set up the on ground variable to true again. So let's do that. If this dot clip dot y is greater or equal that our constant for ground, which is ground y. If that happened, first we want to, in case that is greater, we want to put the y coordinate to be equal. So let's start by that, and then we can say this dot on ground equal to false, to true, because we are on ground again. And then we want our dinosaur animation to change from jumping to run. So that will be similar to this one. Let's copy and paste that. And then instead of putting jump, we put running or run. Let's test this out. And we can press the C button, which is the jumping button, and we are seeing that the dinosaur is very happy that now can jumps. Go back to the code. Now let's go to the game manager. Now let's create another method called setGameOver. So we can call this method from other classes. This the gameOver equals to true, which is setting the gameOver flag to true, so this update will not run anymore. Then we want the player or the dinosaur, if it's running, we want to stop the animation. So let's add that dot player dot clip dot body dot stop. So let's try to trace this whole thing in our code. So our player is a instance of the class Dino player. If you go to that class, you will see that we have a clip there, and that clip is Dino. So Dino, if you enter to the Dino, at the run frame you have two objects, the collider but also the body. Same with the jump, you have the collider and the body. And through our code we are telling the body to stop the animation. So right now by default the animation is running, but if we put that line of code, the animation will stop. So that's what we are doing there. So that's our, whenever we want to set the game over, so we are telling we are setting this flag to be true, but also we are telling our Dino clip body to stop. Then lastly we want to set up the text for game over. So go txt, which is this one. Let me copy the first one, copy, paste, and then just write game over like that. So let's go to the level system. The level system will be in charge to spawning our cactuses. So in this way it will contain a cactus list. So let's do that. This the cactus list equals to empty list. Okay, now let's go and program the cactuses because our cactus class is empty. Okay, so for our cactus, since we have two cactuses into our stage, cactus 1 and 2, the one is the smaller one and the second one is the tallest. So we need to specify which clip we will be using for the cactus. So we need to declare or define a parameter here in the constructor for the clip. And then since we only have two cactuses, we need to clone them. So let's do that. This dot clip equals to the clip clone. So we are cloning that clip. Then so in order to determine whether this cactus is colliding with the dinosaur, we will be defining the collider for the dinosaur here. So let's do this dot dino collider is equal to game manager dot player dot clip dot collider. The game manager has a player here which belongs to the Dino player class. So that class has a clip which is the Dino, and if you enter to the Dino you will see that we have a collider object here. So that's the one that we are using in the cactus class. Now let's add a method to verify the collisions. Let's call it isColliding. And then we only want to check if it's colliding with the player if we are as a coordinate less than the 600. Now, if that is true, we want to check if the Cactus collider is hitting the Dino collider. So the Cactus has a collider, which is this .clip, which is the Cactus collider, hits the Dino collider. Copy, paste. If that is happening, then we want our game manager to go to game over, which is the function that we just programmed. Set game over. Then let's add a method or function for remove the Cactus. Remove me. First, we want to reference the Cactus list that is in the level system. So that list will be Cactus list equals GM, game manager, level system dot Cactus list. Because every Cactus will be inside the Cactus list, which is system, level system, Cactus list. Then we want to know what index from that Cactus list this Cactus is on the list. In order to do that, we say clist dot index of this, which is the Cactus. And then we remove the Cactus from the list. Maybe splice. And then index 1. Then we also remove the Cactus clip. This clip. So we are removing this Cactus from the Cactus list of the level system and also removing the clip. So that's what this function is doing. Now for the update, we want to use this function whenever we are less than the left corner. So if the Cactus, which is this .clip.x, is less than maybe -30, then this remove me. Let me copy and paste that name. Remove me. Else, if we are on the stage, we want the Cactus to be moving at ground speed, because the Cactus doesn't have any legs, so ground speed would be the speed of the Cactus. So now additionally, we want every Cactus to be verifying if it's colliding with the Dinosaur. So we have to put this and then call this function. So basically the update function for the Cactus is to verify if the Cactus is already out of the screen, so we can remove it, but also to move the Cactus if not, and also to verify that the Cactus and the Dinosaur are touching themselves. So now we have to program the level system so we can spawn the Cactuses. So for our level system, we need a variable to be to store in which level we are currently at. So level number, which will be fine. It will start at level 1. Also how many cactuses or group of cactuses we are spawning. Spawn number. Let's start that at 0. Then we have some kind of timer, so we can spawn the cactuses at some point. So t for time equals to 0, and then this the time max equals to 300 frames. Maybe at the beginning we don't want to wait this quantity here, 300 frames. Maybe we can set up this to be 150, but then when we reach this 300 frame, we want maybe to reset this to 0 instead. So now let's create a function for spawn cactuses. Spawn cactus. Then, as I mentioned, I will spawn the cactuses based on the level number, so we need a switch statement to differentiate in which level number we are. This level number. And then case 1. So we will have 3 different level numbers. So for the level 1, we need a function for this spawn level. A second function for level 2. And a third function for level 3 or so. Now we need a timer function that it will change in the level numbers. So let's put maybe level timer. And then we can say this.t plus equal 1, so we are increasing our time. Then if our time is greater than our time max, we want to spawn some cactuses, but let's reset the timer to 0, and then we call this function to spawn a cactus based on the level, and this dot cactus. Then, since we spawn some cactuses, we will be increasing the spawn number by 1. Then we want to increase the level number whenever we have spawned 10 cactuses. In order to do that, we will be doing this the spawn number modulus 10 whenever that is 0. So every 10 spawn cactuses, the level will increase by 1. So this dot level number plus equal 1. So now this function will be on the update of the level system. So every single frame it will be adding a 1 to our timer, and whenever we reach 300, it will reset the timer to 0. It will spawn a cactus. It will increase the spawn number by 1, and every time that the spawn number is a multiple of 10, it will increase the level number. So the idea is that if we start on level 1, we spawn 10 cactuses within level 1, and then it will pass to be level 2, other 10 cactuses within level 2, and it will pass at the default, which is level 3 or more. Let's define now these 3 functions. So 1, 2, 3. So I will start defining a cactus. Let 10 cactus. and then temp cactus equals new cactus, and then in here we can select which clip, because the cactus accept what is the clip, cactus clip. So let's start with the cactus one. Here, cactus one. And then we have to put that cactus into our cactus list here. So let's do that. So this the cactus list dot push, and then we are pushing the temp cactus. So now in our level system update, we need to include this level timer. So let's do that. Copy, update this dot paste, and we want also to update the cactuses because the cactuses don't update themselves. So for cactus of our cactus list, we do an update. So let's try this out. You see how based on the timer it will be spawning the cactus one, and it will disappear when it reaches the left corner, which is what we wanted. And we can also wait to see if we can jump 10 times. Okay, we reached the point where we have spawned 10 cactuses. Now we are in level 2, but since the level 2 function is empty, nothing is happening right now. So now let's test the game over. But now within our level 1, we want some randomness between cactus 1 and cactus 2. Let's do that. Let's go to the level system. So in here we can add an if statement. If, let's do a random thing, random.integer from 0 to 5 equals 0. Then that means that inside here it will happen only 20% of the time, and the else will happen the 80% of the time. So 20% chance and 80% chance. So in 20% I want the cactus 2, which is taller than the cactus one. So let's do that. Copy, cut, paste. In here I will change the clip to be cactus 2, and that should be enough. Let's do that. Let's see if we can see the 20% chance here. Right here. Okay, that is working fine. Let's return to our level system, and then we have our first level properly programmed. Let's do something different for level 2. So for level 2 we want to spawn maybe 2 cactus at the same time, separated by a gap. So let's do that. So we will need maybe cactus 1 and cactus 2, and then in here cactus 1, cactus 1, cactus 1 and cactus 2. And then 20% of the time we want maybe cactus 1, cactus 2, this combination, one small and one tall. And for the 80% we want both to be smalls, so cactus 1, cactus 2, calling the smaller cactus both times. And then we are pushing that, but we want a separation between those two clips. In order to do that, we want to say the second cactus to be separated maybe dot clip dot x plus 170 should be sufficient. Let's try that. So this is working. We are starting seeing level 2 and we have, oops, we reached the 20% chance, which is fine. This is working as expected. This is cool. Now we can go ahead, and now that we know how this is working, we can set some mask here so the user or the player don't see what's going on behind the scenes. In order to do that, let's go to the code layer and click there, and then do some zoom out with the mouse wheel, and then choose rectangle, put 0 for the round corners, and start doing something like here, then a second one here, a third one here, and the other ones here. And then we are supposed to see only what matters. So for the level 3 we will do the same thing. Let's go to the level system, spawn level 1, spawn level 2. Now for the level 3 we want 3 cactus at the same time, so let's copy the entire logic and put it into level 3, and let's add a third cactus. Copy, paste, 3, same chance. Let me add a third cactus here. Cactus 3. So for the 20%, maybe I want cactus 2, one tall, one small, and one tall. And then for the 80%, maybe I want, let's see, small, tall, small, the other way around. And then we need the same, almost the same space between the cactuses, so let's do the same thing for the third one. The third one needs to be 170 after the second one, so we can put in here. Let's change this to be the double of this one, which is 340. And then let's test this out. So basically this is it. We have a working application. We have our dinosaur with the running animation. We can go forward, backwards, we can jump, and we are triggering the jump animation, which is working fine. Then it switched to the run animation, and we can spawn cactuses based on a level. Since we are in level 1, we are spawning 1 cactus at the time, but also with a random thing going on, so we can select between smaller cactuses and the taller ones. Also we have our ground and mountains with a parallax scrolling effect, which is nice. And we have the scoring system, which is refreshing every single frame. That is a nice effect as well. So we are currently in level 2. We are jumping 2 cactuses at the same time for each spawn number. And hopefully we can pass this level 2 to see the level 3. Let's see. I could also add sounds for the jumping, and we are in level 3 already and I lost. But I think that it's possible to jump in this way, it's just that I didn't do it correctly. It's a good space between the cactuses and everything is working as expected. This is a good tutorial to learn a little bit about object-oriented programming and to have the code in one page completely and organized, and you don't have to jump and switch between codes and remember where the code of something was in the editor. So you have everything in one place and you can close always, the classes, and you can find everything within one code very easily. I hope you enjoyed this tutorial. See you next time. Thank you.